Hey Bears, Madden here. We are starting bonding this week. There are actually three types of bondings that we discuss. We talk about ionic, covalent, and metallic bonds. Our tests are going to be split up. Our first exam is going to cover ionic bonding, so that's where we're going to start off. And so before we get into, actually putting these elements together and looking at how they bond together, there are some very basics that we have already been discussing that we need to review. And so I'm going to give you some definitions, and we're going to look at the periodic table and look at some patterns of elements that tend to bond with each other more than others. Before we start, you need to get your notebook because it is incredibly critical that you take notes. You're at a point where if you're not using your notes or don't have any notes anytime we take an exam, not sure what's going on there, and I would highly emphasize to you how important it is to take advantage of this opportunity. The other resource that you need that is critical to being able to determine chemical formulas in bonding is you need to have a periodic table. Without a periodic table, unless you have it memorized, this is very difficult. I've been teaching chemistry for a long time now, and I studied chemistry for a while. I still need a periodic table to help remind me certain things. So, that being said, please email me if you need a periodic table. We're working with our team in order to figure out how to get those or make those available to you if you don't have a printer and you need one. All right, let's go ahead and get into this. Ionic bonding is the first type of bonding that we're going to spend time focusing on. Ionic bonding is, let's see if we can do this, is a bond between a metal, which we call a cation, and a nonmetal, which we refer to as an anion. This bond is not a very strong bond. It's these ionically bound chemicals tend to be very brittle, which means they're very they're just not strong. They dissociate when you put them in water, which means they will separate. They're made up of ions, and we'll talk more about what an ion is here in just a second. But understand that an ionic bond is essentially between a metal and a nonmetal. Understanding what an ion is kind of central to understanding how a metal and a nonmetal would come together to form a bond. An ion is an atom that has an atom or molecule in some cases that has either gained or lost electrons. I've already given you there are two types of ions that we're particularly going to be looking at. The first one is the cation, and the cation is a metal atom that typically will lose electrons. And there are different reasons why elements lose or gain electrons, for that matter. And usually it's to have to be in its most stable form. We took time when we were looking at periodic families, looking at alkalis, and just to kind of briefly give you an idea, again, we looked at sodium. Sodium is an alkali metal in the group, which is group 1, and it has 1 valence electron. This 1 valence electron, with its electron configuration that is 1s2, 2s2, 2p6, 3s1, makes this incredibly unstable. Ideally, it would prefer to be in a more stable position and have a configuration that ends at 2p6. So, what sodium will do naturally is it will give up this electron and it will form a cation, so that now we have something like this. This is the cation of sodium, which is much more stable than sodium, regular sodium by itself. Now, you might be wondering, okay, well, why does it become a positive charge? Well, sodium has 11 protons. And in a neutral state, like this sodium right here, it theoretically also has 11 electrons. Now, if I took 11 positive charges and then I added 11 negative charges, my net charge would be 0. There's no charge. For every proton, there's an electron that offsets the charge. And when you have a positive plus a negative, then it's 0. It's exactly like if I said, okay, 1 minus 1 equals 0. Kind of the same idea when we're adding the protons and electrons. But in the case of the sodium cation, it still has 11 protons, right? That's what makes it sodium. Except in this situation, it gives up 1 electron. So now it only has 10 electrons. And when I'm trying to offset every proton with every electron, what I end up with left over is a +1, because I have one more proton than I do electrons. So that's where the additional charges come from. An anion is a nonmetal atom that typically will gain electrons. We could look at chlorine. I like chlorine. We use chlorine a lot. Chlorines, chlorine is has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. This is the Lewis structure of chlorine. Chlorine's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Ideally, all elements want to reach the P6 position. Everyone wants P6. They want to have this P6. Most elements do. At the end of their configuration. And we see when we look at the Lewis structure of chlorine, it needs one more electron to fill every one of its outer orbitals. So in order to do that, it is very electronegative. Remember we talked about electronegativity, and that elements that are near fluorine, the halogens, are very electronegative because they want to fill their outer shell, and so they will tend to take electrons, steal electrons from other elements to attain the 8. And chlorine does just that. So we end up with the anion of chlorine, where chlorine's anion will be Cl with a minus 1. The electron configuration of that particular of the anion now is 1s2, 2s2, 2p6, 3s2, 3p6. And we see the P6 come into play because it has now gained an electron, because of its electronegativity, its high effective nuclear charge. Now, if we look at chlorine, chlorine has 17 protons. And in its neutral state would have 17 electrons. And if we were to add all the 17 positive charges to all the 17 negative charges, our net charge would be 0, which is what this chlorine has, a net charge of 0. But when we look at the anion version of chlorine, it still has 17 protons because that's what makes it chlorine. But it now has 18 electrons because it gained an electron. So now I have 17 protons plus charges, and I have 18 negative charges. I'm going to be left with 1 extra electron, making the overall charge a -1, which is why we see the -1. You're not going to have to do this math. The reason why I bring it up, and of course it's not difficult math. I mean, it's very fundamental and basic. But the reason why I show this to you is so that you understand where this is coming from. And we call these our oxidation numbers. Our oxidation numbers are critical to us determining what the formula would be in bonding. So oxidation numbers indicate if an atom has gained, or I shouldn't say it like that. I should say it like this, sorry. Oxidation numbers indicate how many electrons an atom gains or loses. A positive oxidation will tell us that it's hard. I'm trying to keep this like all consistent, like where I'm not like talking like all broken, but that's kind of hard, and type at the same time, so it's kind of hard. But anyways, a positive oxidation tells us that most of the time, there are always exceptions, I'm still learning them. Positive oxidation numbers tell us that there is a cation that lost electrons. And the reason why the oxidation is positive is because it now has more protons than electrons. So whatever the net charge is, if I take however many protons and add it to however many electrons are left, I'm still going to be left with an overall positive charge. The actual number will tell us how many were lost. So if the oxidation is a +1, that tells us that atom lost 1 electron. If the oxidation is a +2, then that tells us that that atom lost 2 electrons, and so on. If it's a +3, then it lost 3 electrons. When we have a negative oxidation indicates to us, typically, there's that little preface again, that we have an anion. An anion that has gained electrons. So when we see an oxidation number that is -1, then that means that atom gained 1 electron. If the oxidation is -2, then that means that atom gained 2 electrons. If it's a -3, then we know that that atom gained 3 electrons. It's about offsetting the charges and understanding that when you have a positive, it's lost electrons. When the oxidation is negative, it's gained electrons. And the number that goes with the plus or minus tells us exactly how many electrons were lost or gained.